by vector method. Prove by vector method. Sin A minus B. Sin A minus B equals to sin A cos B minus cos A sin B. Okay, sin A cos B minus cos A sin B. So, are you familiar? I think you are very familiar about this problem, because the last year, that is 2012, this coming the last academic year, so this problem comes under your 10 marks. Came, right? Therefore, which is equals to, this is very important, one of the problem. So otherwise, similarly, we have another problem, sin A plus B. So sin A plus B means sin A cos B plus cos A sin B. This is also very important on exam point of view. This problem is also one of the important problem, frequently asked question. Okay, now you are just going to solve the problem. Similarly, let us take the axis, x axis and y axis, then z axis. So I told you already, unit vector for x axis is y vector, j vector and k vector. So from this we are making an angle, XOP is equals to A and XOQ is equals to B. Then we can say angle of POQ is equals to A minus B. This is all about the diagram. This is the figure. From this we are going to construct, we are giving some construction and we are going to prove the problem. Okay. Now, in XOY plane, we are considering angle of XOQ or XOP equals to A, angle of XOQ is equals to B, angle of POQ is equals to A minus B. Take L and L dash on OP and OQ. The similar one to the above problem. We are putting L here and we are taking L dash in OQ. Join LM and L dash M dash. Okay? Join LM and L dash M dash perpendicular to x axis such that OL is equals to OL dash is equals to 1 unit. So therefore we form two right angle triangles. Here two right angle triangles. So OLM and OL dash M dash. Similarly to the above problem, we are taking two right angle triangles. The first right angle triangle is OLM. Okay. From this I can able to find out sin A, opposite side, that is ML divided by OL. We know your OL is equals to 1, your ML is equals to 1. Therefore, your ML vector is equals to, ML passes through the y-axis. Am I right? So y-axis is what? It is a j vector. Therefore, I can say sin A j vector. And then cos A vector is equals to adjacent side, your OM by OL. Your OL is equals to 1. Therefore, your OM equals to cos A. Otherwise, we can say your OM vector is equals to cos A. OM in the direction x-axis. Therefore, it has a unit vector I vector. Similarly, in right angle triangle OL dash M dash, your sin B is equals to opposite side, that is your M dash L dash divided by OL dash. M dash L dash divided by 1. Therefore, your M dash L dash vector. So M dash L dash, we know that sin B. If it is in the direction M dash L dash, it moves to the y axis, the unit vector is j. Therefore, I can say sin B j vector. And then next one, your cos B, adjacent side. Your adjacent side is OM dash divided by OL dash. So OM dash divided by OL dash is equals to 1. Therefore, your OM dash vector is equals to cos B towards x-axis. Therefore, I can say this is I vector. Now I am going to find out what is OL and OL dash vector. Okay, now I am going to find out what is OL and OL dash vector. Okay, now using the triangle law of addition in vector algebra, we can say your OL vector is equals to OM vector plus ML vector. OM vector plus ML vector. So using the diagram, we have found out that ML, OM vector, M dash L dash vector and OM dash vector. Just you substitute. Now you can say OM is equals to cos A I vector, cos A I vector, plus ML vector is equals to sin A J vector, and OL dash vector is equals to OM dash vector plus M dash L dash vector. So what is OM dash vector? Cos B I vector plus sin B J vector. So up to this almost similar, but there in that first problem we are used the property of dot product. Now I am going to using the property of cross product. Okay, now you just find out that use the property cross product, we will get so OL vector cross OL dash vector. So I, J, K. This is the way to find out the cross product. Cos A, sin A. No K vector 0. Cos B, sin B 0. Therefore, we will have I vector into, no, we will not get I vector and J vector. Therefore, only simply we will get K vector. K vector into this row, this column cancel. Cos A, sin B minus sin A, cos B. Okay. So if you take minus common outside, we can say minus K vector into sin A cos B minus cos A sin B. Are you clear? So we have minus K vector into sin A cos B minus cos A sin B. Let us consider this as first equation. Now by definition of a vector algebra, my vector product, by definition, suppose we have two vectors, A vector and B vector, then we can say modulus of A and modulus of B sin theta n cap is the definition for the cross product. Similarly, if you want OL vector cross OL dash vector, we can say modulus of OL vector, modulus of OL dash vector into sin, the angle is A minus B for OL and OL dash. Now what is the vector, unit vector here? I told you n cap, in definition it will be n cap. Here we have to find out the unit vector. The OL and OL vectors, in the diagram we have seen that your OL vector and OL dash vector, it moves opposite to the z axis. If it is comes downwards, we can say the unit vector for z axis is K vector. But OL and OL vector are moves opposite towards the direction of z axis. Therefore, the unit vector for z axis is K vector, which is it moves opposite to that. Therefore, we can say it is minus K vector. Therefore, the unit vector is minus K vector. This becomes 1 and this becomes 1. Therefore, your OL vector, OL dash vector is equals to minus K vector into sin A minus B. Now compare 1 and 2. The left hand side is OL cross OL dash. Here is also OL cross OL dash. Therefore, we can say sin A minus B into minus K vector is equals to minus K vector into sin A cos B minus cos A sin B. So therefore, we will have minus K vector will get cancelled. Therefore, the remaining one is sin A minus B is equals to sin A cos B minus cos A sin B. Hence proved. So I hope it's very simple, right? So the first one is using dot product. Now we are using cross product. So both all are similar. The last step we are using the cross product. There we are used only the dot product. This is all about these two problems. We'll have 4 problems based on this concept. Another 2 are cos A minus B and sin A plus B. I hope you all very thorough in this 2 problems. Okay, we'll pass on to the next